Okay, so now we're going to do a little bit more with conditional statements. Here's our example. If it is a square, then it's a rectangle. This, as a reminder, is the hypothesis. And then then it's a rectangle, this part is the conclusion. Just as a note of emphasis, not part of the hypothesis, not part of the conclusion. So there's really 4 parts to a conditional. If, hypothesis, then conclusion. Okay, so this statement we know is true, right? That statement we know is true. Now we have some other things that go along with conditional statement. This we would call the original statement, right? So there we go, a nice original statement. We could also negate each of these. So we could say, if it is not a square, if it is not a square, okay, then it is not a rectangle. Okay, so that statement we're going to call the inverse. So this is the inverse when we negate them. The inverse is not always true, right? If it's not a square, then it is not a rectangle. Okay, well actually, I can do a nice counter example. So this is not true. And I can have what's called a counterexample, this is an important word. Okay, counterexample, here's a counterexample. Here's a shape that is in fact not a square, but it is a rectangle. So the hypothesis is met, but the conclusion is not. So not true. Okay, we could also take the original statement and flip-flop the hypothesis and the conclusion. So we could say, if it is a rectangle, so it's positive again, then it is a square. Okay, that is called the converse. Okay, so all we're doing is we're flip-flopping the hypothesis and the conclusion. This, in this case, is also not true, okay? And a counterexample would again be this shape, right? The hypothesis is met, that's a rectangle, but it is not a square, so the conclusion isn't true, okay? And last but not least, we could do both things. So we could say, if it is not a rectangle, then it is not a square. Okay, that's what's called the contrapositive. Contrapositive. Okay, and assuming that the original statement is true, then this statement also has to be true. Okay, so these 4 statements, original, inverse, converse, contrapositive. If you're given an original statement, you need to be able to make the other 3. That really just takes practice. If you can figure out that something's not true, can you make a counterexample? And again, a counterexample, write this down. A counterexample is when the hypothesis is held true and the conclusion is not. So here, not a square, hypothesis held true. But it is a rectangle. Okay, for this converse, same counterexample will work. It is a rectangle, but it is not a square. One other thing about contrapositive. So in your original statement, and I'm going to make a new one, let's say if it is let's say if it is a regular shape, it is equilateral. Good note, regular means equilateral and equiangular. Okay, so a square is regular. Okay, again, hypothesis, conclusion. Okay, the contrapositive is something just to know, which in this case is if it is not equilateral, then it is not regular. Okay, that is also true. Okay, so here's an important thing: the original and the contrapositive are what we call logically equivalent. Are logically equivalent. Okay, so what that means is if one of them is true, they're both true. If one of them is false, they're both false. So if you can decide, oh, hey, this original statement's true, then we know the contrapositive is true.